Okay, good morning. So this is section 18.5. 18.5 is about multiplication of radicals. So first we're going to review, because I used that before, multiplication property of radicals. So a and b are real numbers such that radical of index n of a and radical of index n of b are both real. So then you can use the multiplication rule. If you have radical of index n and inside of the radical you have a product, a times b, this is the same as radical of the same index of n of a times radical of the same index of n times b, which means, example, let's say if you have cube root of x times y, we can rewrite that as a cube root of x times cube root of y, okay? Or you can have an opposite. Let's say you have square root of 2 times square root of 8. So since both of those radicals have the same index, which is 2, you can rewrite that as a one radical, so square root, and you can multiply the numbers. 2 times 8, and that will be square root of 16, which is 4. Okay, so this is the multiplication rule. Again, in order to use multiplication rule, make sure that the index of radical is the same. Okay, so it has to be the same index. Okay, so let's solve some of the problems. So example 1, multiply the expressions and simplify the results. Okay, and the first one will be 4 in parentheses, 4 square root of 6 times negative 2 square root of 3. So again, I put them in a parenthesis so you guys understand that this is multiplication between them. So what we're going to do? First of all, distribution property. So we can always multiply the coefficients together, of radicals together. Doesn't matter what index the radicals have, but we can multiply them together. Okay, so multiply. So we will end up with 4 times negative 2. And then you can just rearrange everything else. This is square root of 6 times square root of 3. So we end up with negative 8. And now we can use the multiplication rule of radicals because we have square root. So the index is 2. So you can just put one radical and multiply the numbers under. So that will be 6 times 3. Okay. So we have negative 8 square root of 6 times 3, which is 18. And now you want to check if we can simplify the square root of 18. Square root of 18 we can rewrite as 9 times 2. This is the same as square root of 9 times square root of 2. Square root of 9 is 3, so this is 3 square roots of 2. So now we're going to rewrite radical of 18 as 3 radicals of 2. So we have negative 8 times 3 square roots of 2, multiply the coefficients, so we're having negative 24 radicals of 2, and that will be our final solution. So next example, B, we have 3ab square root of b times negative 2 square root of ab. Okay, So first what you want to do, it's a multiplication. Start with multiplying the coefficients. Multiply the coefficients. So again, those numbers, they not under radical, so you can always multiply them. Multiply coefficients. Okay, so we multiply the coefficients, so we have 3 times negative 2, that will be negative 6ab. And then rewrite everything else. We have square root of b times square root of ab. And now here, look what happened. We have negative 6ab, since both of those radicals have the same index, which is 2. So we can rewrite that as a square root and just multiply the expression. So this is b times ab. And of course, you need to simplify that. So I'm going to simplify this. So let's show work. Square root of BAB is the same as square root of A times B squared. And now you can rewrite that as a square root of A times square root of B squared. And again, we know the square root of B squared is just B. So we have square root of A times b, which is just b square roots of a. So square root of BAB is b square roots of a. So let's just plug it in. So we have negative 6ab, and then that part, b square roots of a. B square roots of a. So now just simplify. Here b times b will give you b squared, so we have negative 6a b squared square roots of a. That's the final solution. Okay, so you always want to simplify, okay? So now we are applying all the rules which you guys learned about radicals. C, we have 2 radical of index 3 for AB times 5 radicals of index 3 2a squared b. Okay, so what we're going to do, we always multiply the coefficient first. So we have 2 times 5, which will give you 10. And just rewrite everything else. Cube root of 4ab times cube root of 2a squared b. So since both of those radicals has the same index, we can rewrite that as one radical and just multiply the expressions under radical. So that's 4ab times 2a squared b. So that will give us, continue, 10 cube root. Let's combine like terms. So we have a times a squared will give you a cube. 4 times 2 will be 8. A to the third power and b squared. And I will go back to that answer. I just want to simplify this because you definitely can simplify that expression. So showing work. So let's simplify cube root of 8a cube b squared. So this is the same as cube root of 8 times cube root of a to the third power times cube root of b squared. So cube root of 8 is 2, because again you can rewrite 8 as a 2 to the third power. So like you see when the index and power are the same. So this is just 2. Here the power and of A and the index are the same, so we end up with A. So we have 2A, and cube root of B to a second power can't be simplified because exponent of B is being raised to a second power. So in able to simplify the radical, this exponent should be 3 or greater than 3. So we just copy down the cube root of B squared. Okay. So here I was showing work how to simplify again the cube root of 8a cube b squared. So so they are equivalent. Let's just replace that. And our final solution will be 10 times 2, let's put it that way, 2a cube root b squared. And this is just 20a cube root b squared. Okay, that's the final solution. Okay. Next, what we're going to do, we're going to multiply radical expressions. So we're going to continue. We'll use a little bit of distribution property. So let's just give you a note for our next examples. When multiplying radical expressions with more than one term, we use the distributive property. So let me show you how that's going to work. Let's do example 2. Okay, so we're going to multiply, and we have 4a. We have 5 square root of 5 times 2 square roots of 5 minus 2. So here what we need to do, we need to use the distribution property. We need to multiply each expression in the parenthesis by 5 square roots of 5. So distribution property. So that you 5 square roots of 5 times 2 square roots of 5 minus 2 times 5 square roots of 5. Okay, so let's simplify that now. Okay, let's simplify this. So we multiply, so we know how to multiply the radicals. We multiply the coefficients together, so that will be 5 times 2, which is 10. And then we have square root of 5 times square root of 5, which will be square root of 25. 5 times 5, you put in 25. And the same thing here. We multiply coefficients, so negative 2 times 5 will give us negative 10. And we just have square root of 5, which we copy. And that will give you square root of 25, it's 5. So we have 10 times 5, which is 50, minus 10 square roots of 5. Okay, and let me see if they want to leave the solution that way. Yeah, so you can leave the answer that way. Okay. Let's do checking. We'll make sure that I'm going all the examples which you will need it to study. So let's do more. to b. We have 2 square roots of 3 minus 3 square roots of 10 times square root of 3 plus 2 square roots of 10. So here you have expression times expression. So what you're going to do here, you're going to FOIL. Okay, so here we're going to FOIL. Okay, so again, you have 4 expression, 1, 2, 3, 4. So FOIL, F, multiply the first one together. So we have 2 radicals of 3 times square root of 3. So that's F. All multiply outside. So that will be plus 2 radicals of 3 times 10 square roots of 10. I stands for inside. Which is negative 3 square roots of 10 times square root of 3. And L stands for last, which is negative 3 square roots of 10 times 2 square roots of 10. Okay, so now it's time to simplify. So we use the FOIL, okay? So here we have 2 square roots of 3 times square roots of 3. That will give you 2 square roots of, multiply the numbers, 3 times 3 will give you 9. 2 square roots of 9, which is 3. Now here, plus, first what we're going to do, we're going to multiply the coefficients. So 2 times 2 will give you 4 square root, and now you multiply the numbers under radical, so you have 3 times 10, which is 30. Now we're moving next. We only have one coefficient, so I copy that minus 3, and square root of 10 times square root of 3. You put 1 square root and you multiply the numbers under. So that will be square root of 30. And the last part, we'll multiply the coefficient first. So we have negative 3 times 2, which will give you negative 6. And then we have square root, and we're going to multiply the under numbers under square root. So 10 times 10 is 100. Let's simplify that. So again, we know that square root of 9 is just 3. So we have 2 times 3 plus, let me just wait with that plus. Now here, look what happened. You have like radicals. Hope you guys see it, that they both have radicals. So we can subtract those radicals. So that will be radical of 30 outside. And we have plus, and we're subtracting the coefficient. So 4 minus 3. Minus 6, and you guys know that square root of 10 is just 10. Minus 6 times 10. Let's simplify that. We have 6, 4 minus 3, it's 1, plus 1 square root of 10 minus 60. So that will give you 6 minus 60, which is negative 54 plus square root of 30. Okay, and square root of 30 can't be simplified, so that will be our solution. Okay, so that will be the answer. Okay, let's continue with more problems. What would you do? One more. Okay, see. So I have square root of t plus 3 square roots of w times 4 minus square root of t minus square root of w. Okay, equal. So here what we're going to do, we're going to apply also the distribution property. Okay, so just be careful. We're going to multiply each by each. Okay, so first what I'm going to do, I'm going to take that square root of t and multiply by each. So square root of t times 4, or you may think about 4 times square root of t, will give us, just copy, 4 square root of t. So don't forget that you have number multiplied by radical. So 4 is just the whole number, doesn't have radical. So you just multiply the coefficient. And in front of square root of t, of course, you have 1. So you multiply the coefficients together, the same rule, 4 times 1, it's 4, radical of 2. Next, we have square root of t times the next expression, which is negative square root of t. So you have plus square root of t times negative square root of t. I will simplify that later. I want to show work. Next, plus square root of t, we're multiplying by negative square root of w. So negative square root of w is just negative 1 square root of w. And we continue. Next, what we're going to do, we're going to take positive 3 radicals of w and we're going to multiply by each. So 3 square root of w times 4, so we're multiplying the coefficients. So 3 times 4, that will give us 12 square root of w. Then we have 3 square root of w times negative square root of t. So let me show work. Plus 3 square root of w times negative square root of t. And the last one, plus 3 square roots of w. We're going to multiply that by negative square root of w. So just be careful here. Make sure that when you distribute, multiply each by each, you take the expression with the operation in front of it, because that's very important. So that negative radical of t means negative 1 square root of t. Negative square root of w means negative 1 square root of w. Now it's time to simplify. So I showed it at work. So we have 4 square root of t. Now here you have radical of t times negative radical of t. So don't forget that this is negative 1 here, and this is 1. So I multiply the coefficients together. So 1 times negative 1 will give me negative 1. We'll just put like negative. And we have radical of t times radical of t, it's t squared, which eventually that will give us t. Now here the same thing. So positive times negative expression will be negative. And we have the same index, so we're going to multiply the numbers under radical. So this is tw plus 12 square roots of w, okay? And then I'm continue here, so I have 3 times negative 1. I multiply the coefficients. 3 times negative 1 will give me negative 3. And then I multiply the numbers under radical. So 1 radical, because they both have the same index, and you have wt. And one more. Then we have 3 times negative 1, which is negative 3. And we have under square root, we have w times w, which is w squared. Okay. So time to simplify. 4 square root of t minus, we know the square root of t squared is just t. So this is minus t minus square root of tw plus 12w square root of w minus 3 square root of wt minus 3, and we know the square root of w squared is just w. So if we can, we should combine like terms. Okay. So 4 radicals of t. I only have one expression like that, so I'll just copy this. We have 4 square root of t. I only have one expression like that, so I just copy that, minus t. Now let's see if we have expression which have radical tw. We have wt, so that's the same. So we're going to simplify that. So that will be plus inside of the parenthesis. Don't forget that in front of this radical it's -1. And we adding the coefficients, so -1 minus 3. And you copy that radical of tw outside. Okay, so we definitely can combine them. We can subtract them because they are like radicals. And the last one, we have plus of w. It's only one. I don't have like term like this. Minus 3. So when you simplify radicals, you think about like radicals, you think the same way like terms. They need to look alike. Okay, so we have the final answer for radical t minus t. -1 minus 3 will give you negative radicals of tw minus 12 square root of w minus 3w. Believe it or not, but that's the final answer. Okay, I cannot simplify that better. Okay, so we have to get used to all of that. This is the last section of this semester. Next one. Now I'm going to give you notes. So I want to talk about the expressions of the form parenthesis radical of index n, and you will like that. Inside of the radical, your radicand, it's a, and outside you have n. Let's talk about those expressions because this is the formula. We're not going to prove it, but the radical of index n of a, and if everything will be raised to the power of n, it is just equal. If the exponent and the index match, that will be just equal a. Also, this is equivalent. This is the same thing as radical of index n of a, and if you put that power inside radical with radicand, so that's still the same thing. When the index and the power match, the solution will be a. Use it all the time when you see it. Okay, you can simplify a lot of stuff. So we're going to apply that in examples. So an example. Simplify. We have a square root of 14, and everything is going to be bring to the power of 2 equal. So we know that the index of square root is 2. Since we have the same power and the same index, the solution will be just 14, number under radical. Okay. B, we have radical of index 7, Q, and everything is going to be bring to the power of 7. The same idea, powers are the same, so the solution will be just Q, the radicand. And last one, from those type of problems, radical of index 5, 3z, and everything to the power of 5, index and power match, so your solution is radicand, which is 3z. Okay, that's it. That's what we're doing with that. We'll continue in a second. Okay, so this formula, the radical of index n, square root of a to the power of n, very easy. It's always associating radical. Next one. Okay, we're going to talk about special case products. Special case products. Okay, special case products. So this is the one we're going to call about perfect square trinomials. So that's the format which you guys should know. A plus b square, we call that square of sum, is equal a square plus 2ab plus b square, and that's been proved. If you follow your a plus b times a plus b, that's what you always will end up with. So we call that, this is square of sum, and the other one is square of this difference, a minus b square. This is the same as a square minus 2ab plus b square. Square of difference, you can prove it, just follow your a minus b times a minus b. Square of difference. We're going to use those formulas to simplify the radicals. So let me give you the examples. So square the radical expressions. Okay. So first one, we're going to have square root of a minus 5 to a second power. So I'm going to use square of difference formula, which is a minus b squared for a minus 2ab squared. So in this case, if we're talking about our formula of a, it's been a from the formula, and 5, it's been b. So you can apply that formula, a minus b to a second power, which we know is a squared, right? So in our case, a, it's square root of a. So we have square root of a to a second power. Then I follow the formula, minus 2. So the formula is minus 2 times a times b, minus 2 times a, my a, it's square root of a, times b, my b, it's 5. And then I follow the rest of the formula plus b squared. So in my case, b, it's 5. So I have plus 5 squared. So this is how you apply the square of difference. We just need to simplify. So now we learned that when the radical and the power are this, when the index of radical and power are the same. So from here we're just getting a. Now here we have negative 2 times 5, which will give you negative 10 square root of a. 5 to a second power is 25. And that will be our final solution. Okay. And B, example B, we're going to use the square of sum formula. So here we have 4 square roots of x plus square root of 3 square equal. So here we're going to follow the formula a plus b square, which is a square plus 2 times a times b plus b square. Okay, so this is a, and this is b from the formula. So we have a square which will be 4 square root of x. We need to square it. Okay. Then we follow the rest. Plus 2 times a times b. So a is 4 square roots of x, the entire expression, times b, which is square root of 3, plus b squared. So b squared is square root of 3. Okay. Okay, so let's simplify that. So this is what happens when you have a product and the power outside of the parenthesis, you're going to distribute that power to both. So this is 4 to a second power and square root of x to a second power. Now here, 2 times 4, you can multiply the coefficients, so that will give you 8. And we know that when the radicals have the same index, you can write them under one radical, so that will be x times 3, which is 3x. And here's square root of 3 to a second power, the index and the exponent and match, so that will be just plus 3. So let's simplify that. We have 16 square root of x to a second power is just x, plus 8 square root of 3x plus 3. And that's it. We don't have like terms. We cannot simplify that better. So this is the final solution. So I show you how to use perfect trinomials formula, which is the square of sum and square of difference with radicals. And here we have 2 more objectives to cover in this section. Next one, I will talk about multiplying conjugate radicals. So it's a nice shortcut. So multiplying conjugate radical expressions. So let me just review quickly. Let me recall conjugate. Conjugates. So let's say if you have expression x plus y, the conjugate will be the same expression but with opposite operation in the middle. So that's the conjugates. Or let's say you may have square root of x plus 3. The conjugate will be square root of x minus 3. So the only change is the operation in the middle. Okay. Also, another example conjugate, you may have x plus square root of y. The conjugate will be negative x minus square root of y. So again, just don't forget that we only switching the operation in the middle to opposite. So that's the conjugate. So when we multiplying the conjugates, okay, so this is the formula. Product of conjugates, so a minus b times a plus b. So this will multiply the conjugate. It's equal to a squared minus b squared. Very nice formula. Okay, so use it. When you see the conjugate, don't follow, just apply straight that formula. Okay, so the same pattern, multiplying 2 conjugates. So we call that, if you want to write this down, the product of 2 conjugates binomials. Binomials, we call binomials because you have 2 expressions in the parenthesis. is equal to a difference of squares. Of squares. So this is the difference of squares, a squared minus b squared. You will see how nicely that formula works. So let me show you the examples. Multiply the conjugates. Multiply the conjugates. And let's do example A. We have square root of 5 plus 3 equal square root of 5 minus 3. So definitely you guys see that we have conjugates, okay? The same expression, just opposite operation in the middle. So use that formula, a squared minus b squared. So again, a plus b times a minus b, okay? Square root of 5, it's a, 3, it's b. So using the formula, a squared minus b squared. So we have square root of 5 to a second power minus b squared, which is 3 to the second power. And that will give us just 5 minus 9, which is negative 4. Okay, so very nice solution. Let's do one more. B with conjugates. We have half square root of a plus 2/5 square root of b times half square root of a minus 2/5 square root of b. Okay. So here you also have conjugates, so you see the same expressions but just opposite operation. So we have conjugate. 1/2 entire expression, 1/2 of a will be a from the formula, and 2/5 square root of b will be b from the formula. Okay, so let's just apply that formula, which is a squared minus b squared. So a squared everything, which is 1/2 square root of a, we need to square it, minus b squared, which is 2/5 square root of b square. So again, don't forget that you only can use that formula when you have conjugates. So that will be equal. Since you have a product, you have to distribute the power. So that will be 1/2 to a second power square root of a to a second power minus, and we distribute that power to both. Same thing. So we have 2/5 to a second power square root of b to a second power. So don't forget that that minus doesn't represent that b, which is your 2/5. 2/5, it's not negative. b, it's 2/5 square root of b. So let's simplify. So we have 1/4 square root of a to a second power is just a, minus 2 to a second power is 4, 5 to a second power is 25, and square root of b to a second power is just b, and that will be our final solution. So this is how you apply multiplication of conjugates. And there's last objective of this section about multiplying radicals with different indexes. So last one, multiplying radicals. Because don't forget that everything what we've been doing had the same indexes. Now they will have different indexes. Multiplying radicals with different indices. Okay, So how are we going to do it? So when you have the product of radicals with different indexes, so what's going to happen, we'll have to solve those problems a little different. So let me just give you a second. Okay, so here guys, multiplying radicals with different indices, which is different index. If you have case like that, what we're going to do, use the properties of rational exponents to obtain common index, which means we're going to change radical expression to exponential expression and simplify. So note, change radicals to exponential expressions and simplify, and then we'll change it back to radicals. I hope you guys remember that the radical of a and m is the same as a to the power of mn, or radical of n of a, and the exponent is outside. This is still the same as a to the power of m over n. So that's what I'll give you the example. Multiply the expressions, write the answer in radical form. So let's do the example. Example A, we have square root of x times cube root of x. So again, it would be wrong if you would do this, that this is the same as square root of x times x, and you would just copy index or something. So this is wrong, okay? What we need to do, we need to change each expression to exponential. So square root of x, the index is 2, the power next to x is 1. So this is the same as x to the power of 1/2 times x. And again, index of cube root, it's 3. Next to x to the power 1, so that will be x to the power 1/3. And now using the properties of exponents, since bases are the same, so you copy the base and you adding the exponent. So this is 1/2 plus 1/3. So again, we're using the property a to the power of n times a to the power of n. So that exponential rule, product of the same basis, you can rewrite that as a, which is the same base, and you're adding the exponents. Okay, so that's what we're using here. So now we're just going to add the fraction 1/2 plus 1/3. You need to count the denominator, which is 6. So this is the same as 3/6 plus divided by 3 plus 2. Okay, so we multiply, we get in common denominator, and that will just give you 5/6. So here we have x to the power of 5/6, and now since the answer has to be written in a radical form, so we need to change that to radical, which will be radical. X goes inside, you guys remember, the denominator is always the index, and 5, the numerator of exponents follow the base, follow x. So this is my answer. Okay, so we cannot solve that different way because the index of those radicals are different. Okay, and let's do example B. You have radical of index 4. Okay, so the last example. So the same thing, we have to, since the index of radicals are different, so we need to change them to exponential expression. So radical of index 4 of a to the power of 3, this is the same as a to the power of 3 over 4. And then radical of index 3 of b, if you don't see the exponent next to b, just put 1. So this is the same as b to the power 1/3. So that will be equal to a to the power of 3 over 4 times b to the power of 1/3 okay. Just give me the second, because this one it's a little different. Okay, so this example it's a little different because look what happened. We have different bases. So when you have the different bases, what you want to do with those exponents, you want to rewrite powers using common denominator. Okay, so that will give us a, and 3 over 4 and 1/3, the common denominator is 12, times b, and the common denominator will be 12, so that will be 4. Okay, let me just rewrite that. And let's just simplify that. So again, a 9 over 12 times b to the power of 4 over 12. So what we can do here, okay, we can rewrite that as a to the power of 1/12 and everything being raised to the power of 9, because I'm using here power of power property, times b to the power of 1/12, and then everything is going to be bring to the power of 4. So I'm using the power of power property because what happened, I'm trying to simplify that. This problem is a little more tricky. So again, 9 over 12, I just rewrite as 9 times 1/12 over 12. And the power 4 over 12, I just rewrite as 1/12 over 12 times 4. So now what we're going to do, let's just rearrange that. So we have, okay, here we can rewrite that as that way, as a to the power of 9 and that to the power of 1/12 times b to the power of 4, and that everything is to the power of 1/12. Okay, and since they both have the same power right now, so we can rewrite the expression. Going to use the power rule, we can rewrite that expression as a to the power of 9 times b to the power of 4, and that which repeats will be outside, which is 1 over 12. I'm using the power of property. So Again, using this one, a to the power of n m, because look at what happened. That power 1 over 12 will be distributed to 9, so we'll have 9 over 12 like originally, and that power 1 over 12 will be distributed to 4. You'll multiply, so you have 4 over 12. And now, finally, we can change that to radical. And you're treating this one as a one expression. Okay, so we're going to have a radical of a to the power of 9, b to the power of 4. Okay, now look what happened. The denominator becomes index, and numerator goes right here. So that will be just radical of index 12 of a to the power of 9, b to the power of 4. Okay, so that was a little more tricky problem, but that's the last one. So we only worry about simplifying and multiplying those radicals when the indexes are different. So example B definitely was more challenge. I think I want to solve you guys more just to practice, and then I will be done. So we have 3 square roots of 7 times square root of 2. We're going to rewrite that as 7 to the power 1/3 times 2 to the power of 1/2. And what we want to do, we want to rewrite 1/3 as 3 over 6. I'm sorry, 2 over 6. And we want to rewrite 1/2 as 3 over 6. So our exponents have the same denominator. So this is the same as 7 to the power of 2 over 6 times 2 to the power of 3 over 6. Okay? And what we're going to do next, we're going to rewrite that as 7 to power 2, and then everything to the power of 1 over 6 times 2 to the power of 3, and everything to power 1 over 6. Because again, if you apply power of power property, 2 times 1 over 6 will give you that original. And now what we're going to do, we're going to distribute 1 over 6 outside. So that will give you 7 squared times 2 to the 3rd power and 1 over 6, it's outside. So 7 squared is 49, 2 to the 3rd it's 8. So we have 49 times 8, so that will give us 392. So this is 392 to the power of 1/6. And now we can change that to radical. The index is the denominator, and you have 3